course. Hold on, yeah. All right. So sorry about that. Wow. Just had to help out my friend. They had some questions, and I had to be a good friend and help them out. Thank you for joining me. I have to, when I download this and repost this, I will go ahead and cut out the silent parts. This is Carter Drew. This is Let's Build a Cloud Architecture. So what you're looking at on the screen, let's move that. You are looking at draw.io. This is the architecturing software that I use to go ahead and make different architectures and things like that. So I figured let's go ahead and do this because I see a whole bunch of YouTube videos on what it's like to get an architect job, how to study, which those are all very important. Those are all good. Those are all great. And I'll eventually have some content like that on my other channel, Cloudy by Nature. You guys may see that in the thumbnail. That's going to be my new channel that I'm going to start. But I'll be doing all of that content, but I also want to do the technical work because there's not enough videos showing technical examples of architecture work and how to do it, right? So I want to fill that niche and be the person, be the channel that I wish I had when I first started. And to some extent, I'm still learning. So we're learning together. So let me turn up the music. House music is one of the best musics to listen to while you are architecting. Deep House, Gentleman Radio, one of my favorites. Let me see here. So this is the full toolkit that you're seeing, Draw.io, Angie's Boutique. I got a friend named Angie. So her shop came to my name, or it came to my mind. So we're going to go ahead and what we're going to create today is what I'd like to call a e-commerce website example. And it's going to be a 3-tier architecture diagram. And we're going to, one of the best practices that I've learned in regards to making an architecture is to use cloud agnostic technology. What does cloud agnostic mean? Cloud agnostic means open source, open stack software that any vendor can use that works for just about anything. There are some technologies that you can use: Amazon, AWS services, Azure services, which is Microsoft, GCP, which is Google Cloud Platform. They all offer their versions of some of these cloud agnostic technologies and services. But it's best to build it from an agnostic point of view. That way you can run it based off of just the baseline agnostic services. Or if you're working with a particular vendor and want to utilize a particular technology or a particular vendor, you can go that route. It's basically becomes a plug and play when you know the actual building blocks of what we're looking at. So let's take a look. So what we have here, let's say this will be in the Amazon cloud. Let's maybe we won't say Amazon cloud. Let's see here. We'll just say cloud. Or a fun thing you can do, edit style, and then just take out, they won't teach you this at home. You take out, they be killing that shit, man. Let me see if I get rid of that. What it's gonna look like. I did too much. All right, so not that line of code. Shape. MX graph. Oh, here we go. Graph icon. So we can get rid of the graph icon. And that should still... yeah, did it. So it got rid of the icon, so we just put cloud. And that's how you can take some of this stuff and make it for your use. So one thing that's going to be constant is your VPC, your virtual private cloud, and then you have your cloud within the cloud. So it's the cloud, just going to be your OpenStack cloud. Just put open source cloud, and then we got a VPC. Now what we can do is make this a bit bigger. The good thing about Draw.io has the major icons for just about all of these services: AWS, Azure, Cloud, just basic cloud enterprise, Cisco, Citrix, GCP, IBM, Kubernetes. That's big. VMware, Veeam, Rack, Office, Network, you name it. And let's make that bigger. Let's take Angie's Boutique down a bit. Yeah, let's take you down a bit. All right. So let's see here. I like that it reminds you to save too. Exit out of that. Okay. All right, so let's just look at this. So what's going to be happening in our cloud? This is going to be e-commerce website. So let's just say that this e-commerce website, what's going to be within the virtual private cloud. So let's say the virtual private cloud of this e-commerce website, Angie's Boutique, it's going to require, let's say, 6 web servers and 6 application servers. It's typically what you're going to have when you're looking at most web pages. Now, obviously, the servers, let me say the best way to put this, it's going to depend on what you're particularly doing. Sometimes you need 10 web servers. You'll need less. You'll need more. It really just depends on the scope of the project, how much those particular virtual machines are going to be gigabytes wise, so on and so forth. But this is just going to be super general. So let's just say Angie's like, okay, I'm going to need I'm speaking to Angie's IT officer of her company, if there's an IT officer. We're just going to want to make sure that the website works well, performance for the users, and that if there's heavy traffic or a lot of traffic, that it won't, gunk up the performance, and they'll be able to fulfill requests through the e-commerce website. Okay. So what are we going to need? Let's go ahead and put this here. We'll put web server fleet. And we'll duplicate that. Remember, I said we're going to need a application server fleet. Now, with these, you can use any icons you want. I tend to actually freestyle a lot of this, but you can use, there's tons of icons you can use. So we're going to need 6 of them. So let's duplicate. Put virtual server. You can always undo right here, and there's delete there. This is a handy tool too. So right now, this is overlaying this, but if I wanted to make this go, this will now overlay that. And if I want to, that's there. If I want to put it back, we'll put that behind. There we go. So that puts it in front. This will put this behind. Well, this will put this in front, depending on where it is. Whatever you overlay, this is how you put one on top of the other. There you go. Make it simple. Then duplicate. And that's 6 right there. Now you can do the same thing, or you can just, what I like to do, boom, save you time, know your tools. All right, so those are our 2 sets of servers. Boom. Now coloring is very useful. So let's go ahead and color these yellow. Probably could have colored them before I mass duplicated, but I don't know. It's kind of therapeutic filling in the boxes. Let's make the cloud blue. And color coding just helps for the ease of the diagram. You can use whatever colors you want. Okay. All right, so we got those. Put that there, put that there, put that there. All right. So we got that. Now, she said that she wanted to make sure that if traffic for the website gets to be too crazy, that it'll automatically scale to help that. So, what are we when we talk about scaling? We're talking about scaling and elasticity. That enables a architecture or a particular part of an architecture to expand and contract based off of use and need. So you can set up parameters like, let's say, at 30% capacity of the network traffic to create another one of these virtual servers. You can do that, and so on and so forth. You can absolutely do that. And then that will make another one of these pop up to help the load, to help the performance of the system. So she said she wanted to make sure that these auto scale. Auto scale is, again, that virtual expanding and contracting of the system to create virtual servers to help the load. So let's just use, I believe we can use some of these. Just know it's going to be agnostic, aka not necessarily Amazon, but we're going to use a symbol for auto scaling just to show. And then the cool thing here, auto scaling. Man, how y'all like that house music? I love that. I love it. All right. So now this whole server fleet is going to be able to auto scale, which means whenever there's a situation where we're going to need more servers to be able to take care of the traffic of the website during burst times like sales, or times where there's not a lot of network traffic and you don't necessarily need more virtual servers than this. Let's just say it's going to take 6 virtual servers minimum to run the system. This means that it can go ahead and if it like burst up to adding 2 more, it can retract 2 more, so on and so forth. Think of it like the system is breathing. All right, now for these virtual servers, there's got to be a data repository for this particular e-commerce website. We'll call this the database layer. Now, you can use different types. You're going to want a database. So we can just put here, make this smaller. We'll just call you database. Remember, we want to keep it agnostic. Database. And then we'll make you red. Database is red. Now, you can make within a given time, you can make things called read replicas. And what are read replicas? Because this website's going to take a lot of traffic. There's going to be a lot of people accessing it and reading what's on the website. It's going to need it potentially may need put a lot of stress on the database, pulling information from the database to the user. So at that point, you'd want to create a read replica, which is like a virtual copy of the database, almost like a virtual server of the actual database that will help with the where it can read the same things that are within the database, and it'll take the load off the database. So in this particular case, let's put 2 database read replicas, or you can also call them database instances. But let's just for the ease of use of this video, we'll just call them read replicas. Well, actually, let's go ahead and not to do that. Let's duplicate. And let's do a minor differentiation. The database will be that, and then we'll make these lighter versions, the read replicas. Database read replica. Cool. All right. So now that we have those, you'll have your instances, your virtual services or your virtual servers pulling from the database. And then they're going to be continually pulling from the database in this instance as traffic comes into this particular virtual private cloud. Now, we got the main meat of what this VPC or virtual private cloud is. So at this point, we're going to have to funnel it to the user. So let's go ahead and do this. Oh, that's weird. All right. So what we're going to need on there's something called an elastic load balancer. So you know how the auto scaling group will create virtual servers at a moment's whim, depending on, the higher settings like 30%, 60% capacity. Well, the elastic load balancer balances out the network load that's coming in to the e-commerce application website. So we are going to need elastic load balancer. And then, like I said, we can use this, just know it's elastic load balancer. Or we can just call it a load balancer. How about that? Keep it simple. The agnostic term for that is load balancer. AWS is the one that puts elastic in front of it. Nothing wrong with that, just a different marketing choice. Now, you're going to need, since that's going to, and let's put some arrows to show you kind of how this works. So you've got load balancer. It's going straight here. Boom. And we got this going here. And then sometimes these will go and these will read from here. And then these will read from there. And then sometimes this will read here. So you kind of see the flow of how it works. Now, let's go ahead and put user here. So we're going to have users there. And like I said, you can just kind of look general resources. So you have the users, people that uses Angie's Boutique's website. We got users here. And then what are they going to be using? So for the users to get to this web application, they're going to need to go through an interface. These are called CDNs, or content delivery networks. Amazon has Cloud Front. There's other CDNs, content delivery networks for each particular major vendor and provider. So again, we're going on the plug and play premise here. So we just put all right. Now, it can't just go from there to there. How are we going to connect this? So all of this information in the database in these virtual servers are nothing but, since this is a boutique, what she's selling are different clothing items and things from a particular provider from where for her store. So her boutique, let's say it's going to have dresses, um, tribal wear, bracelets, things like that. It's going to need a lot of pictures. May even need videos showing models within the clothing or using the particular items. All that information is going to be stored in the database in these read replicas here. It's these virtual servers that are going to pull from there, and then it's going to pull and send that to the load balancer. The load balancer is going to fulfill the request that the users are sending. So think of it like a big circle. Now, the load balancer, upon receiving the request, it's going to pull that, and then it's going to send that to, it's got to go somewhere here. It's got to go to another repository. Now, this is what we're going to call object storage. Object storage is just like it sounds. You put an object within a container, and that container, depending on what your settings are, can be accessed by a whole bunch of different providers, private and public networks, users, so on and so forth. But there's two things that you need. Let's go ahead and create the bucket for the network. Well, no, let's do the bucket last. We need something before the bucket. How is the outside internet, the users, going to be able to get to essentially a private, virtual private cloud? How is something public going to get to a private? Well, that's where you would have your DNS server come in, your domain name server. A lot of people, if you think about domain name, you think of like GoDaddy. You think about YouTube.com. That's a domain name. Peggy's Pancakes. That's a domain name. Now, there's a lot of services that you can buy a domain name and then you can route it to a load balancer or route it to a particular object storage bucket, so that that website can directly get information from their repository, object repository. So this is going to need a domain name server, so we can go ahead and create one. All right. Now we can go ahead and put our bucket. The DNS can route to the object storage bucket, which is going to host all the static web pages as well as videos, other things that are requested from the user. This process is what you see, when you click on a page at Amazon, click on an item at Amazon. That request, what you don't see within those milliseconds, is a request going from here to here to here to here, and back here to you. So let's go ahead and put our bucket, and I think we actually find something that looks like a bucket to help you visualize that. Yeah, the bucket. There we go. We will make you no. We'll just make you green again. There we go. Okay. So in that, what we see here, that's pretty much it. So what do we see here? Let's think about this. Let's wrap it up. So what are the things that we used? We use virtual servers, which are here. Different names for it. EC2 instances with Amazon, virtual machines with Azure, and there are compute engines with GCP or Google Cloud Platform. So you have your virtual servers that are within an auto scaling group for your web server fleet. You need the same exact thing for your application server fleet for your virtual servers as well. These virtual servers take information from the database and it phones it through, upon request, through to the network load balancer. And then that'll go through the DNS server, which will go to your bucket, and the content delivery network can display the contents of the bucket per your request, finding that particular item and getting it to you, the user. In the event that there is a heavy traffic due to anything like a sale or a holiday time, something of that nature, the load balancer will balance out that traffic among the virtual servers to make sure that the system continues to run at a good performance level for the user. With the auto scaling group, in the event that it reaches a threshold of 30 CPU capacity or 60% CPU capacity for these virtual machines, it'll spin up another one to go ahead and help in that load to continue to provide the best performance for the e-commerce website or application. In the event that things slow down and we don't need all the extra capacity that was just spun up, or it can not only add but also take away virtual servers. So you can see how you can have a system that is almost organic, right? It can fix itself. It's got self-healing properties. It can ramp up when it needs to. You don't even need to do anything. It can wind down when there doesn't appear to be any need for all the extra compute power. When you're dealing with cloud, it's often paid as you go. So you're going to want these things in place so you're not paying too much for your bill. A company can get the most out of the applications that are created for them, and so on and so forth. So that would be, if Angie wanted me to make an e-commerce website for her, this is what I would do. E-commerce website, EX application, that's how you do it. And that would be a cloud native setup. If she had her own data center, then we could connect that to this particular virtual private cloud, but she wouldn't need to. Now, if this was a bigger enterprise like a hospital or a data center, Then we get into migrating data or adding data or connecting an existing data center to a virtual private cloud. So I hope that was helpful. Again, I will cut this up. I'm sorry that I was not available towards the beginning. Just had an emergency call, but I will cut this up. And it's going to not be as long of a video as it is here. And hope it helps you out, makes sense. I'll continue to make architectures and do my thing. And I hope this helps. Let me know. Do you guys have any architectures you guys have been working on? What do you guys need help with? Let's help each other. I might have a Discord group for my new channel that I make up for Cloudy by Nature. When Cloudy by Nature comes up, I'm going to put a link in the description. Please like, comment, subscribe on here, and like, comment, subscribe on there. Let me know how we can help each other. This is the technical part. If you can get the technical part down, understand why we use things, why we're putting things where we're putting them. There's a lot of background work that you have to do. You have to understand networking, BGP, just baseline architecture design. Understand why we're using things, how we can provide solutions, and also fix things. Part of being an architect is not only creating architecture, it's integrating it, migrating it, and in some cases fixing architecture that's there before you. So I hope this helps, and I hope you have a wonderful and safe day. As always, keep it real, and peace.